Hi, very good morning all. This is Radhakrishna Prasad and welcome to Advanced Performance Engineering Training Program. So today for the demo one, we'll be talking about what we teach, okay, what is the end result of this course or how this will help you and what are the things that are actually covered from different aspects, especially client side, server side, network side, operating system side, and what monitoring tools that will be covered, what are all the web app DB service we actually cover as part of performance engineering. All these things will be explained to make you understand what we really teach and how you are going to benefit from this program. Okay. So about me, like I'm Radhakrishna Prasad, and I have close to 13 years of experience in performance testing and engineering. Like every other performance engineer, performance tester, I started my career in performance testing using different versions of LoadRunner, then Apache JMeter, NeoLoad for some time. And I have involved in each and every individual phase of performance testing life cycle, engineering life cycle, right from the non-functional requirement gathering till the sign off. And from the last few years, as I worked in practice teams and center of excellence teams, I was actually taking care of multiple projects from different verticals, defining roadmaps for multiple stakeholders who really don't know what performance testing is and from where they have to start. So I also have experience in training many people in performance testing. I have published so many articles on LinkedIn, DZone, and I have given uh, some technical trainings on various platforms. You can find my videos on Matrix Performance Engineering channel tutorial. And I have also experience working with monolithic architectures, microservices architectures, on-premise and SaaS-based, which is cloud-based architectures. And if you talk about our mission, right? If you see a mission, if you take many of the organizations or many of the projects, regardless of any years of experience a performance tester may have, they are restricted to something like basic to complex scripting, not completely into many aspects of performance engineering. Like you will have NFR gathering knowledge, then creating a performance plan or creating a strategy and effort estimation. You decide that you are expert in some basic scripting to moderate to complex scripting executions, then publishing the report in the way the customer wants it. Many of the performance engineers are still facing challenges on how to interpret the results, what level of what percentage of understanding what percentage of performance improvement has been achieved from release to release. All these things are uh, not actually there just because even if you're a performance engineer working for a BFSA client or a secured client, you are actually having not having access to the not having the complete control over the environment to the servers. You may have only view access to the Dynatrace or AppDynamics. So when it comes to performance engineering, right, our mission is to transform, help every performance tester to become a performance engineer by giving them some advanced topics with real hands-on training. Like you can create your own setup. You can take multiple heap dumps or dumps like in real time. You can take GC logs. You can analyze GC logs. And when it comes to monitoring tool, right? Any monitoring tool, you can just open the monitoring tool and you can see what's happening with a specific target machine, be it web server or app server or database server. If you're monitoring something like a component DNS, you can also monitor DNS safeguards. Or if you're monitoring a CDN, if you're monitoring load balancer metrics, you have some thresholds and you have a big list of metrics, and you try to understand what's happening with each of the component and how the system starts degrading. So that's not the expectation of a typical performance engineer role. So what we do here is we'll explain you three main monitoring tools, Dynatrace, and the second one is Datadog and Neuralink, and the fourth one is Site 24 Cross 7. where you can create your own setup. We'll teach you how to install an agent on a target machine like Oracle Database Server or SQL Server, or MySQL Server. Or if you want to install an agent like on the application servers like IIS for .NET applications, Apache Tomcat for Java applications, or if you want to install an agent on a WebLogic server, or if you want to install an agent and configure some parameters on WebSphere. So all these things you can do it on your environment. You can actually install a web server like Apache Tomcat. Then you can install a WebSphere, WebLogic, or Oracle WebLogic, IBM WebSphere. You can install Oracle database, and you can take some multiple AWR reports, ADDM reports, ASH reports. So whatever that is available to us, we have two applications. One is in Java and one is in .NET. So will help you to create your own setup, and what you can do is you can install the tool of your convenience, be it JMeter or LoadRunner, record some sample scripts on that, and when you try to hit it with when you try to exercise your application with 1 to 50 users, right, then it is going to give you some utilizations, and you can configure the agents, install the agents on the target machines, and you can see what's happening inside each and every component of your architecture. I mean, I'll also give you the architectural diagram. So this is the agenda of this is the mission of this program. We are enabling every performance tester to become a performance engineer, where you need to understand the architectural design. You need to understand hardware sizing. You need to understand code profiling, how to do code profiling, how to identify hotspots. Okay, you need, for example, if you're working on client-side performance testing, you need to understand uh, how uh, how to minify CSS and JS scripts, how to compress the images from the front end client side by using Google Lighthouse or GTmetrix or Web Page Test or Chrome Dev Tools, which is improving the performance, or which is reducing the page load time or time to first byte metric in client-side performance testing. So all these things, right? Becoming a performance engineer is little tricky, and it has a lot of learning curve when it comes to working with any new technology, be it SAP, be it IoT, be it Salesforce application performance testing. If you are moving all your applications from on-premise to cloud, if you are moving from one data center to another data center, let's say you have all the web app DB servers, what you're currently testing is on rack space, then you're moving your web application server from USA to Canada, and your database server remains in the same place, then you have to do performance testing to find out what is the latency or what is the time it is actually taking when the request is sent from application server that is sitting in US to the database server that is sitting in Canada. So database migration performance testing, data center movement performance testing, when you're moving applications from on-premise to cloud, or when you're moving applications from microservices to monolithic to microservices, for everything, you need to know how your systems are behaving under different anticipated load conditions, right? So coming to the course content, considering the current market fall, we have seen many requirements from many fellow performance engineers. So again, we have added many changes in the existing course content, and we would like to uh, add that in our program. And like, if you see the first thing, right, we'll initially start with performance testing concepts. When I say performance testing concepts, please remember that we are not going to touch any of the tools like LoadRunner or JMeter. This course is exclusively for people who already have experience in performance testing, minimum 1 to 3 years. One end-to-end full life cycle implementation in performance testing for an associate is required to excel this to understand the basics and advanced concepts of performance engineering. In performance testing, so if you try to know the difference between the performance testers, who are also called performance test engineers, then performance engineers, There is a lot of difference here, because if you complete 1 to 4 levels of cloud, right, or if you complete 1 to 4 levels in development, you will become a senior developer, senior consultant, or senior cloud engineer, something like that. But when it comes to performance testing and performance engineering, some concept from each and every corner is actually associated with performance engineering technology. I mean, performance engineer role. For example, if you ask me, what is that I have to learn? You have to start with basics and fundamentals first. If you don't know the operating system, if you don't know the OS memory management, if you don't know how the kernel is working, if you don't know the network basics, right? You don't understand how a web HTTP HTML protocol is actually sending a request, and how it is opening a TCP connection, how it is doing all the work on each and every single component that is part inside your architecture, be it external or internal. Let's say when you're sending a request, right? You are from the tool perspective, what you're doing is you're trying to measure the response time not with one user. You're measuring it with multiple users or simultaneous users with parallel computing, and users accessing it from different geographical locations at different points of times, with different bandwidths, with different machine configurations, with different browsers, or different devices. So here you are testing all of that and saying that your application is meeting SLAs with respect to performance, something like 3 to 5 seconds as an industry standard. And that is what you are giving it to the customers. So when it comes to performance engineers, it's not just the traditional performance testing that we are actually doing, like with TCS or CTS or IBM, with some projects like HSBC or State Farm, or you can Davita, Humana, all these things. So when it comes to performance engineer role from the last few years, there is no concept of centralized teams. It is not like someone is going to set up an environment and give it to you, then you can run a test, you can create a script. It is nowadays from 1 year experience to many years of experience, 10 years, 15 years of experience. Most of the projects are into individual contributor roles. It's not like an SME or architect or manager. Everyone, he himself is a performance engineer. So it is like a performance engineer's responsibility to involve in each and every individual phase of performance testing lifecycle, performance engineering lifecycle with application performance management. If you just get something like the requirements, from there you have to start defining the workload modeling. You need to analyze the production traffic. For example, you may not be aware of Splunk completely, because you have Splunk administrators. You have something called Omniture, then you have SolarWinds Pingdom, Google Analytics. There are so many tools which will analyze the traffic in production that is already there in production for years. Going to get some idea on what's happening with the end users when people are accessing the application, doing different transactions at different point of times. So uh, the NFRs sometimes, as they are, as they may not be straightforward all the time from the customers, it is again the performance engineer who has to understand the role of NFRs, SLAs, and business volumetrics, whatever you call it, in any project. And it's not just for an on-premise environment. You also need to you also need to understand how to gather NFRs, how to do non-functional requirement gathering for an application that has been recently moved to any cloud. Okay, so NFRs is very important. It's not like a standard interview question. How do you gather NFRs? And you're saying that we have a client questionnaire document where we document all the list of questions, and uh, we get the relevant information from different teams who are sitting across the project. No. So the concept of NFRs is to understand the architectural design, you also need to understand the use case traversals, the typical user roles, the typical transactions, the business concern scenarios, the customer concern scenarios, what's happening inside your prod, what are all the existing performance degradations that your application is currently experiencing. And the other challenging point is, if you're building a new application right from the scratch, how do you gather NFRs is a very typical task. It's not like you don't have competitor in the market, you don't have application in production, you don't have baselining in benchmarking. The customer is not having enough knowledge in performance testing or engineering. So it is when you have to take the complete ownership. And if anything goes wrong, the entire effort, what you're putting in performance testing, engineering, APM, then fine tuning something, if you're spending 6 months or 10 months, it will go in vain. So anything that goes wrong, it is going to give you inaccurate results. Okay. So from there, we'll understand step by step the importance of capacity planning, how to do workload modeling, as many of the participants has asked how to do workload modeling from scratch. We are actually trying to publish some case study on how to do workload modeling, on what basis we are going to achieve different parameters when a specific number on TPS has been defined. Okay. And when it comes to common performance issues, many of the performance engineers, if you go and ask them what are the bottlenecks you identified, the most common answer that we hear is we have seen high CPU utilization, high memory utilization, and high disk utilization in network. So what about the other performance problems that you see when you're specific to client side, when you're specific to network side, or there are problems from the operating system side? Let's say when you
हो
work, sorry, can you,
अपॉइंटमेंट अजून मिळायची आणि
okay, I'm sorry. Can you please put your call on mute? Yeah, all of you. Yeah, thanks. So when it comes to the performance issues, right? When you, for example, you are working on a high CPU utilization thing on an application server. So if you want to find out for what reason this high CPU is happening, you might take a thread dump, right? So in that thread dump, the first thing that you do is which threads are continuously running. A thread that is continuously running without changing its state can be the reason for high CPU utilization on application server. That is point number one. The second point is if if you take a thread dump to identify something like a when your application server is crashed, when your application is server is unresponsive, or half of the transactions are failing. So after some time of your load test. So what you do is when you take a thread dump, you try to find out which thread is running, which thread is actually sleeping, then waiting, blocked, to find out the deadlocks and resource contentions. There is a difference between those two. And when you take a thread dump, right, you have TID, which is a thread ID, and you have something called NID. Okay, NID is a native thread ID. So N native threads are the threads something that are managed by the operating system, and these native threads that are being managed from the operating system can also create very big problems for high CPU utilization. So when it comes to performing RCA, root cause analysis, you need to look into different directions. It's not just limited to the resource utilizations like CPU or memory or a disk or network. No, you also have problems with low CPU utilization on application server. You have high CPU utilization on the database server. So if I ask you a question like what are the reasons for high CPU utilization? The immediate next question would be on which server? Is it a web server or database server or application server? Or if you're working with a messaging queue like Kafka or ActiveMQ or RabbitMQ, you also need to find out where your CPU, where your application is spinning with high CPU utilization due to spaghetti code or something. So when it comes to common performance problems, when you're making use of caching, caching has got some algorithms, right, to enhance the performance of any applications. Caching plays a very big role. You need to understand what is the ups and downs of using caching, what are the merits and demerits of using different cache policies, caching algorithms on every single component. And example again, if you take the load balancing, right, load balancer, many of you know that you have a load balancer, and you might know that you have load balancing algorithms. But how about software and hardware load balance? What is the role of I mean software load balancer or What is the role of hardware load balancer? If you see the software load balancers, they're actually there inside your web applications, web servers. Okay, hardware servers, they actually sit in front of the group of the servers. They sit in front of the web servers, and depending upon the load balancing algorithm that you are selecting, it will it will distribute the load evenly, or I mean sequentially, or least weighted connections. Is
Brother, hardware load balancer means, are you referring to CPU, memory, disk?
Can you just, sorry for interrupting, can we take questions in the last?
Okay, fine.
Yeah, I'm sorry. Thanks for that. Thanks for understanding. So I'm just trying to make you understand the differentiation that we have to look at of every single component when it comes to performance engineering. You have proxy server, then you have reverse proxy server, or you have a service mesh, or you have a API gateway. So anything, when something is processing in bulk, or when something is actually uh, exercised on a concurrent basis, which is doing some parallel computing with high amount of traffic, you need to understand what are the different performance degradations that can happen. And there is another, again, you have a challenge where in some of the many of the projects, due to budget constraints, you may not have a monitoring tool. So how do you identify problems from in an isolated mode from web server or application server or database server or something like that? So when it comes to performance issues, you will have so many problems. Like example, 20% of the problems you may see from the application server, sorry, web server. Then 25 to 35% of the problems you may see from the application server, and the remaining 45 to 50% of the problems are directly from the database server. So the primary suspect would be always the database, because database will give you so many problems. It's not just that database is the only reason for primary reasons, but again, you have to, when you have a monitoring tool, with the help of monitoring, with the level of interpretation you make by correlating the metrics, you're going to identify where the problem is. Okay, and that is where our program will help you a roadmap to performance engineering, how to take yourself from performance testing to performance engineering. And production traffic analysis, like I have just explained a way back, production traffic analysis is something, again, you need to know how to analyze the traffic. We have an application, we have a trial that is available with SolarWinds Pingdom, where it can show you the detailed information of how users are accessing the application, from which country they are accessing, what is the rate, what is the bounce rate, what is the conversion rate, or what is the JSPs, Java server pages if it is a Java application, or ASPs if it is a .NET application, active server pages. So all these things are not just limited to one tool. We are using multiple tools to make you understand on how to analyze the production traffic analysis, like the way you do if you have your application in prod, you get web server logs, the historical data for 6 months or 1 month or 3 months, and you analyze that, right? You give that input as you give that input files of web server logs to the Splunk, and you try to take the help of Splunk to analyze what's happening in the production, especially from the end users. Okay, so we're going to talk about performance engineering lifecycle. This is where we're going to talk about some SMEs or some performance engineers who are now taking part in architectural design. So how to do that architectural design, uh, how to choose an effective database for your application. Why are you choosing SQL database over NoSQL databases, or it could be vice versa. Why are you using Oracle over MySQL, or why are you using MongoDB, or why are you using Postgres? For everything, there are like ups and downs for choosing a specific web server or application server or database server. All these things are just because we do that for desired performance. Okay, so when it comes to performance engineering process, we'll talk about architectural design, we'll explain you about hardware sizing. When I say hardware sizing, right, you need to know how what is the performance management process. There are some useful laws for sizing a database system. Okay, so if you want to size a database system, you need to benchmark. Initially, you need to profile that, and you need to analyze the transaction for workload analysis. For example, per day, how many transactions are happening? Per hour, how many transactions are happening? Per minute, how many transactions are happening? And you also have the peak utilization, where you will have how many transactions are happening in peak day. Okay, so you have some user-based sizing, and you also have disk sizing. It is going to measure the row size per table. It is going to measure the number of rows per table. So how to add space for indexes, row expansion, how to add space for database logs, what amount of memory that you need to set in your disk. For example, you have to add space to export all the data into flat files, right? Or you need to add space to the operating system, or you need to add space in the same hard disk for tools, for applications. I don't know how many of you know RAID 5, RAID 6, RAID 10, RAID 1. If you have multiple disks, how are you accessing VMs? You have a big server, right? You have a big server which is called, example, Dell R730XT or 740XT. You'll get with 12 bay or 16 bay. Each hard disk slot will support up to 16 TB. So when it comes to servers, right, it will support up to 2 TB RAM. Then you'll have 48 vCPUs or 56 VPUs with uh, 24 threads or something. So all these things, right, when you get a big server, you will install VMware on that, or you will install anything like hypervisor. You'll break all the VMs into bits and pieces, and VMs are given. So when you have everything on VMs typically will have latency problems. Sometimes when something is not working, you also need to look at your VM, because there could be also a problem with the server, which is happening directly from there. And it is not because of the application code. It is not because of the application server or database server. So there are few things that will go missing. So in the performance engineering process, we'll highlight what are the things that you have to be a part of, and how to streamline something, how to start with something, and how to interfere in something like disk sizing or baselining, how to allocate some disk size to the database logs, or what is the RAID configuration that you have to select, what is the thumb rule. And like that, we have some case studies on helping all of you on how to do hardware sizing, how to do sizing for database, how to do sizing for application server or web server. Or for example, if you're having 300 microservices, which has to run on 20 VMs or 30 VMs in Kubernetes environment or something, which is being completely managed from the pod level and node level. So how do you right size, or how do you decide how many machines are required to run this 300 microservices successfully? On what basis do you decide? So that is where some of the parameters like that are discussed in performance engineering process. And as many of us are not still clear with how to do workload modeling from scratch, we're going to do that. And capacity planning, how to do that. What is the role of capacity planning? Uh, the other thing that if you see here, how to build a performance model from scratch. When you're trying to set up an environment, instead of relying on multiple teams in any typical product-based company, it is the performance engineer again who is actually building everything right from the scratch. If you have a load balancer, you have to set it up. If you have an APM tool, you have to install all the agents and configure on the target machines. You have to set alerts, you have to set alarms, you have to set anomalies. So when I'm saying a performance model from the scratch, here what I'm referring is, I'm referring about the environment which is the mirror image of prod. Okay. So when you're doing performance testing, you're not actually doing performance testing on an environment which is same as prod. I'll tell you why. there is a huge gap between performance testing environment and production environment, because if you go back and see your environment today on which you are actually doing performance testing executions, you'll not have the existence of CDN, let's say CDN, which manages all the static data, or you'll not have the existence of DNS. You may not have the load balancer like the way it is actually configured and set up in the real time in prod. You may not have the same size of the same volumes of data that you have in database in prod. So when it comes to performance testing environment, it is always 1/60 or 50% of what we have in prod, or something like 20% of what you have in prod. But every time you're doing performance testing on a downsized environment, what you can do is you have to ensure that every single instance of what you have in prod should be also there in performance testing environment, because every be it internal external components, if you don't know how components in your architecture are talking to each other, what is the role of each and every component, that particular processing time of that component will go missing when you publish the result or when you perform a test in performance testing environment. Example is CDN will have some time, DNS will have some time. If you are using a caching server like Redis, it is going to have some time. If you don't have the existence of the same thing in your performance testing environment, your performance will be much more faster than prod. If you don't following the same things, the same configuration settings, like the way you do, like the way you have in prod. Example, caching algorithms, how you have enabled caching or you disabled caching, or how you have enabled something like load balancing algorithms, GC algorithms. So the amount of memory that you have set for your application to run. Example, you have to set heap for every single pod that is running. You're running a test on a single pod with 1 GB memory with 50 users or 100 users. You need to find out for what reasons it is actually giving high response time or it is giving you high resource utilizations. Is it okay to increase the is it okay to increase the heap memory on a pod where you're testing with 100 users? Is it just because of the number of users increasing on the server, or is it because of something like uh, excessive consumption that is happening because of some problematic microservice? So we are explaining all of that with some examples. By creating, I will tell you how to build a performance model from scratch, taking all the considerations, actions from what we have in prod. And most importantly, instead of just publishing the results, we are going to talk about uh, how to interpret and analyze the results. As soon as your test is done, you may have 15,000 orders created and 15,000 passed transactions for create order. Are you really sure that that 15,000 orders has been created? So what you have to do is you have to go to the database, access flat files, or you have to query the database to see whether 15,000 orders are created and reflecting on the database table. You can do such type of validations, and you have to interpret, you have to understand what value is increasing with what. Let's say if your hits per second is increasing with response time, if your throughput is decreasing with response time. So all these things, right, you need to correlate and you need to come up with some reasons. And this will happen for initial 8 to not just the performance testing. There are a lot of other things where we are going to talk about network performance monitoring, network performance management, a little bit on cloud performance testing. Then we are going to talk on load balancing, load balancer setup with the load balancer practices, and all these things, right, we will actually cover in the first section. And coming to the second one, right, we'll go with the monitoring part. Especially we are going to cover all the individual metrics for the reason, if you have high CPU utilization without going to any of the servers, how do you analyze that high CPU utilization? What are the metrics you monitor? Can anyone tell me that?
I think using like app dynamic tools, we can know.
Well, let's say that your CPU utilization is high, right?
Yeah.
Be it application server or database server or whatever it is. So let's not go in detail. I'm not looking at the heap memory, non-heap memory, the percentage time that is spent on JET, request queue, request wait time, request connect time, request processing time. I'm not worried about all of that. When I say high CPU utilization, what are the metrics that you need to look at?
You need to collect return
Let's say
star.
let's say you have a task manager. I don't know how many of you have used this one. You will be using the performance tab, no doubt about it. But there is something called the information of this thing. I'll tell you this later. You have a socket. You have 4 cores, which means 8 logical processors. Okay. I'll tell you one simple example. You go to resource monitor. When I say 8 logical processors, if you go to the CPU, right, this is CPU total. When I say CPU total, it is actually showing you the total utilization across all 4 cores and 8 logical processors. Okay. So when I say high CPU utilization, this is the first thing that anyone's look at. Okay. And if you see here, then you have some processes when people don't have monitoring tools, you have processes that are running with process ID, with status, and the process that is running with some X number of threads, and it has some CPU and average CPU. Okay. So when you come down here, if you see CPU 0 to CPU 7, these are all the logical process. Okay. If you CPU 0 to CPU 1, when I say 4 cores, CPU 0, 1, 2, 3, 4, 5, 6, 7, these are all eight logical process. If you don't see any activity that is going on in any of the logical processor, it means that there is a hardware failure. Out of 8 logical processors, if you don't see any green color utilization on the CPU 1, it means that this logical processor is actually not doing anything. You will see some events to find out in case if you have a hardware failure, any processor is not actually exercising as expected, then your CPU utilization can go little high. Okay. So for that, you have some of the metrics like most of the people say that percentage processor time total, right? This is one of the metric that you see for CPU utilization. Then I'm sorry, take time. Percentage user time, which is nothing but the amount of time the user spending on executing the code. Okay. If this is high, then it is actually with the user. For example, if you have this metric like percentage privilege time, percentage privilege time is basically the time that is actually the kernel is spending. It is from the operating system side. So you also have processor queue length, which should not be greater than 2. If this is getting high, then your processor is actually taking time to execute all your tasks. And you also have one important parameter called context switches. Many people will ask, what is context switches? What is context switching in performance testing or performance engineering? So basically context switches, it is going to resume and it is going to stop and it is going to resume work. And if you see the high amount of context switching, low amount of context switching, it is going to tell you what is the problem with the processor. These are some metrics that you will have to understand at least to do some basic investigation on why your CPU utilization is going high on application server or database server. Again, you can go back to other parameters, but at least if you don't know what is percentage processor time total, what is percentage user time, what is privilege time. So even if you see the same thing here, if you open a perfmon, sorry. If you open the perfmon, it's not you can create something like a data collector set or user defined or whatever it is. When you create a data collector set, right? I'm saying RAD or something. If you create next or something, if you're trying to do some performance counter, when you're trying to add performance counters, right? When you try to add the counters, it is going to ask you something like this. I mean, it's not just the processor alone. When you try to select .NET CLR or .NET Git or something, just a minute, I'll show you. Yeah, if you see the processor here, you have so many metrics, but I have percentage idle time. If your CPU is 0% idle, it means that if your CPU is 0% idle, it means that your CPU is 100% utilized. So there are some metrics, percentage user time, percentage interrupts per second, all this information. When you're selecting this one, here it is asking, can you tell me what is this 0 to 7 or total? You know, what is this one, 0 to 7?
Logical processes.
Yes, if you are selecting all instances of total, it is going to add these all metrics to all the instances, all the logical processors. If you want to know the behavior of a specific logical processor, you can select that and you can simply say okay. And when you click on finish, right, it is going to create a data collector set. Whenever you have a test, you can easily start that and you can run it. And there is also some tools like Windows Viewer, Event Viewer, so which are very underrated. But if you don't have a monitoring tool, something like this are definitely going to help you to find out from the application logs. For example, if this is your application server where your Java JVM is installed, or if this is your application server .NET application where your CLR is installed, you need to click on filter current log. I only need the errors, okay, not the critical and all. Once I click on this one, it is going to show you all these things. Okay, if you see the error at this point of time, at any point of time, if you're running a test, if there is a problem from the application server, and if your test is part of this time slot, this time stamp, it is going to tell you at 4:21:58 on this date you have an application hang. When you double click on it, it is going to give you the log name, source name, all these things. But for Windows machines, right, this is the most underrated utility because I haven't seen anyone using this, but Windows administrators will use it. Okay, even the last performance engineering assignments I was actually using Event Viewer on many of the Windows Server machines, where you are going to get all the errors information, you're going to get the labels, the events, and you can easily identify what error you got. I'll also tell you one example. If you have an IAS server, right, you have an application hang. Many of the performance testers or engineers who attended this session, they don't know what is the difference between soft hang and hard hang. There are two types of hangs again, soft hang and hard hang. Basically, soft hang, it happens because of the ASP.NET code. Whatever the code issue that you have, of the code, spaghetti code, you will have soft hangs. When I say hard hang, it is the problem with directly the application server, IAS server. When you have a hard hang, the entire server is impacted. If you have 1 to 4 applications deployed in that server, the entire applications in that server deployed, everything is impacted. For example, if you have a soft hang, only a particular URL or a particular place of that particular application in that application server is impacted. So when you have a performance degradation with the type of problem that you get, monitoring will become critical and essential for every performance tester to understand what it is, what sort of problem it is, and you can take necessary actions accordingly. Okay, so this is a simple thing. But again, when it comes to Puffmon, we are going to tell you how to create the data collector sets. Data collector sets you can start automatically whenever if you're, for example, if you're starting a test every Wednesday from 4 o'clock to 7 o'clock in the evening, you can automatically create an automatic data collector set by giving the start time, end time, and the day. If you select it, whenever your test starts, it is going to run the data collector set, and it is going to give you the report. Not just that. Even if you see this one, last time I was running something, there are also reports actually. If you see the reports in the user defined, I don't know if I have something like this, Apache Tomcat. If you see this, I don't know if I can get this report or not, but you have, okay, that's the problem. So, okay. So you see this one. This is how you're going to get all the metrics here, and you will also get you can see like this. I mean, you can just, if you want to just see the report. Uh, it's I have selected last time when I'm running a test, what is the time that it is actually taking. My application is taking in JIT compiler in .NET, so I selected percentage time that is spent in JIT, and I have selected some of the important metrics because I don't want to overload my local machine. For that reason, I have done all these things. So for that, we have an application in Java where we can do some real-time monitoring on Windows Server. And we'll talk about event here, and we'll also tell you how to search and analyze the logs and events for all the critical messages or errors that you get from any of the Windows Server. Okay. So in the same pattern, we'll also try to explain the Linux performance monitoring, because if you see production servers, or if you see the performance testing environment servers, all these things, right? Why 80% of the databases servers sit on Linux machines? Same applies to application servers. If you go to distributed environments, even if you go to small applications that you're working today in your projects, if you go back and see, many of the applications are sitting on some flavor of Linux. Many of the servers, be it a web server, application server, database server, it could be Red Hat Enterprise Linux, RHCL 7 or 8, or CentOS 7 or 8, and Ubuntu. I think Ubuntu is something like 22 or 24 version. I'm not sure on that. So we'll explain you the differences between the different flavors of Linux. These are the most commonly used ones. If you're working on containerization, performance testing, or orchestration, if you're working on cloud, if you're working on everything on a pod level and node level. So mostly your work will be on Linux, not on Windows. Everything is basically command oriented. You have to be familiar with Linux. You need to have some strong fundamentals and basics from the operating system. You need to know the Linux memory management. You need to know the commands, the external open source utilities that will help you to pull some reports to understand the performance behavior with multiple metrics and counters when some test is run with some X duration and with Y number of users. So we are going to talk about all these things, and there are few scripts, dummy scripts, which will trigger 100% CPU utilization, 100% memory utilization on the Linux machine. So we'll also show you that examples. And after that, we'll start with the Java performance engineering. We'll start from the basics. If you have a question, if you have a questions to what level we need to learn Java. So again, to the first line, I forgot to tell you, if you want to become a performance engineer, you must be a good developer first. Okay. So even if by now you must understand what companies are expecting, what is the typical expectation of a performance engineer with 8 years of experience. Going forward, one programming language is mandatory for any performance engineer to identify the hotspots, to identify the performance degradation, to identify the code profiling, to analyze the heap dump, to analyze the thread dumps, to read the stack traces. For example, if you want to know a method that is actually carrying a complex processing algorithm, how do you find that? If you don't have uh, development experience, you will not be able to do anything. I mean, at this point of time, if people have decided to go ahead with this course, in parallel, if you're sitting 30 minutes a day for the next 60 days on Python, I prefer Python because I feel very comfortable with Python. It has taken 60 days for me to learn Python actually. Doing some coding for learning it for 30 minutes and doing some exercising for 30 minutes actually it created some sort of ease when compared to other languages like C, C++ or Java. But again, if you're learning Java, that is also good because going forward, people are asking for SDET roles uh, with combination of performance testing and Selenium. Selenium automation basically they require Java. And when it comes to advanced performance engineering, if you know Java, right, you'll know the techniques, best practices, and how to fine tune JVM. What are all the different JVM arguments? So all these things will make easy for you to fine tune something on Java application when you're doing performance testing using Java applications. Okay, so from in that perspective, we are going to start JVM like. What is Java JVM? How to install that? What is the difference between JVM, JRE, and JDK? And what are the different types of JVMs that we have currently available in the market? And also, there are so many things that you have to do to enhance and to improve, optimize the performance of a Java application. For that, you need to know how uh, Java, what is the internal components of Java, JVM? Let's say class loader subsystem, how the linking is, how the loading is going to happen, how the linking is going to happen, how the verification is going to happen. Again, if you come to the memory areas, right, runtime data areas, what is heap, what is stack? So what is the difference between heap and stack, and what is young generation, old generation? Why you have multiple server spaces? Okay, how to rightly size the heap memory. You have different parameters. This heap memory settings will have a different setting on Apache Tomcat. You have a different setting on WebSphere, WebLogic. You have a different setting on JBoss. You have to set it differently on a pod or something like that. So again, you need to understand the role of GC because the phases involved in GC, like the mark, sweep, delete, and compaction, the GC types, and GC algorithms like serial GC, parallel GC, then concurrent mark and sweep GC algorithm. Then you have G1 GC, which is garbage first, and you have JGC, epsilon GC, and epsilon JGC, and I forgot the other one. Okay, so there are multiple GC algorithms. If you have a concept of baselining and benchmarking, do you know how one sort of baselining is going to happen? Uh, Earlier, all the applications, the example that I have recently seen, all the applications are legacy applications which are actually running with CMS collector. Now all of them have moved to G1 GC, and now they are moving to some other GC algorithm. So we have to test everything with every GC algorithm. We have to run a test with 100 to 500 users on by changing different GC algorithms, by changing different load balancing algorithms, and we have to correlate and identify the differences between all the tests that has been performed. And coming to the thread pool again, you also need to understand what is JVM thread pool, uh, types of threads, daemon threads, non-daemon threads. So what is JDBC connection pooling? Connection pool, how to set the minimum and maximum number of threads in a thread pool and a connection pool. And most importantly, for all the memory related problems, uh, you will see highest number of performance bottlenecks, be it excessive memory consumption or memory leaks or out of memory error. So all these things, right? You need to understand the basics of memory. Then you have to understand why memory leaks are going to happen. What are the different patterns? What are the reasons? How to fix out of memory errors? And I don't know if you have heard about 80-20 rule. 80% of the performance problems happen due to 20% of inefficient code, which is also called spaghetti code. Okay, with no knowledge on programming, with no access to the source code, with no understanding of the source code. For example, you have a transaction with high response time, right? When you have a transaction with high response time, if you want to see that particular source code, if you want to go to that problematic transaction, if you want to inspect the code, you can run a JProfiler. For example, I have a JProfiler here. Okay. So JProfiler, what I did, I have integrated my uh, JProfiler to the Eclipse IDE. Okay. So if you want to see something like this, I can attach to a running JVM directly. If you have another computer, if you have on this computer, then you can start the new session. You can do the new server integration. You can click on new server, and you can do a lot of things here. But here, when you do new server integration, right, this is where you'll get to know the list of different types of application servers for Java. So if your application server is actually Apache Tomcat 5.x or 6.x, currently it is 10. If it is something like Cold Fusion, or if you have a Glassfish, if you have the IBM WebSphere 9.x, or if you have a JBoss application server, for with anything you can directly integrate profiling. So when you're running profiling, right, you run a profiling tool, but how do you know that this is something you have to profile something on this one. For example, you have a demo server here, or let me close this one because I don't want to give you that. Oh, okay. I'm not supposed to open a JProfiler because when JProfiler is integrated to Eclipse IDE, I have to open the Eclipse IDE. So I'm trying to open the JProfiler. If you have to do the profiling on a specific thing, you can integrate all of that. But if you go to Eclipse IDE now, so what will happen is, basically, when it comes to Java performance tuning, right, JVM performance monitoring plays a very important role because uh, if you want to see what's happening uh, in your JVM, right, you need to monitor some of the key metrics like uptime. Basically, it is going to tell you how long the JVM is up and it has been running. So you need to know the total compile time. Basically, total compile time, what it is going to tell you is total compile time. It is going to tell you if your program is actually consuming huge amount of time in the compilation phase. You can look at the process CPU time, the application process that is actually running on Apache Tomcat or uh, WebLogic or WebSphere. It is going to tell you the total amount of CPU time consumed by the JVM when your application is tested by putting some load. You can see the heap size, you can see the committed memory, you can see the GC time, the amount of live threads, peak threads, daemon threads. Then you have a lot of other things like you can monitor JVM heap usage, server response times. You can look at EJB pool statistics, servlets, thread pools, and if you have a tool like Dynatrace, you'll also get some very good insights. There is a metric like time waiting for a connection, a percentage of database connections that are in use. So all these things, right? You have everything available in place. Only thing that you need is you need to interpret. So if you click profile as Java application. So as I have integrated my JProfiler here, if you have some knowledge in programming, the JProfiler will now profile this code and it is going to show you in graphical representation as well as uh, other information. I mean, you can see the memory utilization going high. I'll also show you how the memory utilization will go high now. Okay, this is a program for a memory leak. If you see the memory here, 11.9, it is going to 12, right? So it is slowly increasing. If you see the pattern of 12.2. So what happens with this program is, this is a pattern of memory leak. The GC is trying to delete all the uh, unreferenced objects, and it is trying to free up the memory, but the memory utilization is going high. So if you see, every time the GC is happening, it will have multiple stop the world events where all the executing threads in the application server will freeze, and your GC pause time will be higher, which will increase the response time of that particular transaction. And also, it will give you the high CPU utilization. Every time the GC is running aggressively or more frequently, it requires more computational power, which means that it will utilize more amounts of CPU. Okay, so like that, when it comes to the monitor Java, right? We are actually on analyzing a lot of things actually. For example, if you are working on a server like Apache Tomcat, there are some of the components that are monitored in Apache when server status and extended status are enabled. Example, if you want to know what are the total number of accesses, it is going to give you the number of times Apache was accessed. You must know, right, how many times my Apache server is accessed. What is my CPU load? And you also have metric like requests per minute in Apache Tomcat. It is going to give you the number of requests per minute. It is going to tell you the throughput, how many of them are successful, how many of them are processed. And bytes per request, it is going to tell you for every request how many number of bytes that are transferred. You will get the number of threads that are active, inactive. It is going to, and the good thing about uh, Apache Tomcat metrics, if you go in detail, right, you also have the server response time. Let's say you have response time of 38 seconds. If you try to know the your web server response time, then application server response time, and their database server response time. If your database server is having 21 seconds response time, then the problem is from the database server. The remaining are okay. Web server and database application server are okay. So isolating the problems is little important here, and addressing common performance problems. I always talk about the memory leaks, the GC part, and the code profiling. These are something which you always need to focus on. And even I'm just not saying to learn programming just to identify all these things. If you want to get a good career opportunity in a big product-based companies, almost all the companies are now having a code pairing round, the live code pairing round. That's the first round. Or the hacker rank round. A performance engineer will be given two programs, and you have to write it, and you have to solve it. And the remaining rounds are easy to clear for your experience. I mean, because all the concepts that are asked are covered in this program. Everything. Okay. And coming to the JVM performance engineering again, I am going to talk about many profiling tools here. I'm going to teach you JConsole, JVisual VM, JMC, JFR. For example, let me show you because how things will be taken forward. Uh, because if you don't get insights on how we are actually taking this course, then it's of no use, right? So for that reason, I actually want to uh, show you something on how we are actually running things. Okay, so if this is not working, then I have to let's try this on. Okay, basically, this is initial heat, maximum heat, and this is another parameter. I'm actually running a simple jar file. Okay, even if your Java application is running on an Apache Tomcat, you will have a process ID that is created. Uh, Let me show you one thing. If you go to program files, then if you go to Java, then if you go to JDK, right? If you go to bin, You can see, I don't think so. JMC is here. Yeah, JMC is here, right? So if you see this simple JMC, this is actually Java Mission Control. This comes with licensing. To some extent, it will work, but after that, you need to pay for that. So if you see here in the local host, sorry, you have to expand this basically. So when you expand this one, basically I have overloaded my system with too many applications doing some R&D. So the system has become really slow, but the other system where I'm actually navigating you through all the different activities, right? We are actually having a 64 GB RAM with i7 processor. So we have some good number of CPUs in that, and RAM and all, which can accommodate two Java applications and two database applications. So almost all the installations of every database, every web server, application server, database server will be shown to you in detail. And it is actually taking some time. Once it is open, I'm going to show you JConsole, JVisual VM, Visual GC, your kit profiler, Java profiler, Java mission control, Java flight recorder, and we have multiple sessions on how to take Java heap dump analysis. And you have to make a note here. If you don't have minimum experience on minimum Java experience, at least the basics of Java, if you don't know, you'll not be able to understand when I'm teaching how to analyze a heap dump. Okay, there are wide number of tools available in the market, like IBM Heap Analyzer. Then you have Heap Hero. Then you have so many tools, open source and commercial tools. But taking a heap dump is easy. But extracting the heap dump file, huge heap dump file, analyzing it, identifying the problems from heap dump is difficult. But the current performance engineer limitation is you can collaboratively work with the developer and you can find out uh, where is the problem, because there is a very big discussion happened in one of the interview with a very big company when I'm giving it. So the developer don't wants to spend more time on the problem. See, he says everything is okay. If the performance engineer doesn't know the programming basics, and if you fail to identify the problem, and if you cannot confidently say this is where the problem is from to the developer, what is the use of having a performance engineer? Is the discussion between myself and the performance practice head. So basically, if you don't have that knowledge, minimum understanding on how things will work in programming, when you have some code snippet, when you take a heap dump, how to analyze it, what are the things that you need to look at, you'll not be able to analyze heap dumps. Even if you go to the development architect, some people, they don't know the GC algorithms, they don't know to analyze heap dumps, thread dumps. That's why uh, analyzing, identifying the problems from heap dumps and thread dumps is not easy task. It's a very tricky and extremely tricky and challenging task, but we'll put the best of ours to make you understand. And with some little practice, when you install some applications, you will get more insights on how to take heap dumps, how to take thread dumps, how to read a stack trace in a thread dump. Okay, I'll tell you one example. If you're taking a heap dump, right? If you're taking a heap dump, let's say that your heap dump file is very big. Let's say it is 10 GB or 15 GB. So, or 30 GB, 28 GB, at least 25 GB. So when you're taking a heap dump, to extract that heap dump and to analyze that heap dump, how much time do you think it would take? You're taking a 25 GB heap dump, right? Do you know how much time it would take? It will take 5 to 6 hours sometimes 8 hours, sometimes it will crash. So when you have 25 GB heap dump file, your machine should also have double the size of what you're actually capturing. If you're double the size of space has to be available on your machine where you're actually taking this heap dump file. If your heap dump file is 25 GB, at least 50 GB of the space has to be free on the machine where you're trying to take heap dump and analyzing it. Okay, and it will take hours to take that, and taking a heap dump on production and analyzing that is extremely tricky. Maybe even whosoever it is doing it, taking thread dump or heap dump, analyzing that or deriving a conclusion saying that this is the problem for this particular scenario is, I mean, I don't think so. I mean, it is the only reason we cannot confidently derive a conclusion. Lot of recommendations are required. A lot of expert opinions are required. We need to collaboratively work with the developers to find out where it is actually wasting too much of memory. So all these things, the same thing applies to taking the thread dumps. We'll use deadlocks, will high CPU utilization, resource contention, memory utilization, disk utilization, and we'll also tell you how to take GC logs, how to analyze GC logs, how to monitor GC. And if you see most of the things, right, there is one metric called percentage time in JIT. That metric is so powerful because the code that is running inside your JVM, the time it is actually taking to uh, compile in JIT compilation phase, if it is too high, right, then there is a problem. That is the reason percentage time spent in GC, percentage time spent in JIT are the two important metrics to assess and to understand the behavior of Java JVM applications. Okay. Memory management, yes, we'll talk from the basics. Don't worry on that. I'll also tell you how to read stack traces, detect memory leaks, what are all the reasons for out of memory error, then excessive memory consumption and memory leaks. And there are different patterns where you see out of memory issues. For example, why do you do endurance testing? To find out the memory leaks, right? Endurance testing, as per definition from multiple blogs and textbooks, endurance testing is to find out what memory related problems, especially to find out if there is a memory leak or it will go to out of memory error, right? So when I say this, memory leaks or out of memory errors, those things happen only in endurance testing. Don't you see a memory leak? Don't we have a chance to see, or is there a possibility to see a memory leak or out of memory error in load testing or stress testing? Yes, no.
Yes, we can see.
Is there is a possibility, right? You might get out of memory error in load test as well. You might get a memory leak in endurance test as well, or in a spike test as well. So it's not that, but again, when you longevity test or endurance test, basically to check the sustainability of the application when you're running it for a prolonged period of time, continuously exercising everything on the environment, you will see how the resources are getting utilized. So I'm going to talk about so many tools, sizing the heap, how to rightly size the heap memory, what is the difference between perm generation and metaspace. I'll tell you adaptive sizing policies, and I'll explain you so many JVM arguments. I'll also tell you how to, on what basis you have to define minimum and maximum number of threads. Okay, and I think I have already told the same thing, but the main aspects in optimizing GC for improved JVM performance are tuning GC settings. You have to definitely take the GC logs. You have to implement different GC. I'm sorry. And you also need to work on reduce object creation, then identifying the duplicate objects, utilizing caching, utilizing proper data structure. All these things are equally important to enhance and improve the application performance, Java application performance. These are some of the real-time application issues. Like I'm going to talk about all of these things, especially from the code profiling. Code profiling will be on a real application using multiple code profiling tools like JProfiler, EverKit, Java JVisual VM, and you have a plugin inside Java Visual VM, which is actually, I think this one. Now, the reason why you are not seeing this one is because you have to start this one here. If you don't start this, the process ID is not created. You have to start this file actually. Now, when you start this one, sorry, I forgot to start actually, but yeah. So when you close this one and when you again open it, right, it will now show you the process ID of the jar file that is actually running. You can connect your process directly to the JVisual VM. And like I said, you have multiple these things where you can see. I mean, we have different plugins on different profiling tools, NetBeans Profiler, Java Mission Control, all these things. And coming to the emerging technologies, right? Most of the stakeholders, most of the projects are now moving to containerization. So how different is containerization from on-premise models or the existing environments what we have now? How containerization, how to make use of or how to utilize containerization to enhance JVM performance or in terms of scalability, how serverless computing is actually helping efficient resource allocation for all the Java applications, especially the JVM. And coming to the machine learning for optimization, if you see, I have recently seen a question, how AI is helping for performance testers or performance engineers. Dedicatedly, we are not relying on AI or using AI, but the recent tech stack that is added to the observability APM tools, Dynatrace or AppDynamics or New Relic, Datadog, they are now built on machine learning and data science platforms, which means the tools are having its intelligence on the application predictive insights. So business service reliabilities. For example, if you have a service that is actually running, it is going to tell you the uptime and downtime for the next 24 hours, for the next 7 days, for the next 1 year, it is going to tell you. So that sort of intelligence has been adopted by the tools, and they are actually giving more and more suggestions for the performance engineers, developers equally to enhance and optimize the performance as per various business demands. So there are so many techniques, best practices, and when you want to move something to optimize performance, something like in a DevOps practice like CI/CD, or if you want to do an automated performance testing, you have a CI/CD pipeline built that is actually that will help you to automate the performance testing and for each of the frequent code commits, frequent changes, for everything that can be easily tested, and where your continuous monitoring has to be enabled. The continuous monitoring has to be, you need to have a effective monitoring strategy for all these test runs to identify the performance problems. The same thing happens with the .NET Performance Engineering. We have an application which will be deployed. That's a real application with real data. We have a .NET Performance Engineering. We have an application like JVM in Java. We have CLR in .NET. In Python, you will have PVM. And we'll talk about, like, we explain JVM. We'll also explain the CLR architectural internals, .NET performance problems, especially IAS considerations and Azure considerations, how things will go bad, things will go good from the performance aspects when it is on-premise, sitting on IAS, or when it is moving to cloud, which is hosted on Windows Azure. Okay, what metrics you need to take into consideration, And like the way you have minor GC, major GC, full GC types of GC in Java, you have workstation GC and server GC algorithms in .NET memory management. Okay. And also like you have young generation, old generation, and metaspace, the memory management of JVM. In .NET CLR, you have small object heap and large object heap. Okay. So again, you have generation 0 collection, generation 1, generation 2 collection, the types of GCs that are running. The GC algorithms are workstation GC and server GC. So you will have high GC past times, you will have stop the world events, you'll have thread pool, connection pool, almost everything will be same. Okay. I'll explain you the difference. And coming to this thing, you can see if you have right monitoring strategy, if your performance goals are not set, if you don't have the right strategy, if you have lack of performance testing, if you don't have clear SLAs, or if you're not giving right sizing to all these things, right? So it will be it will not basically it will not give you something like this. I mean, it may not work as expected. Sometimes everything can go wrong. Okay. So same thing, you have to know, you have to use synchronization wherever it is necessary. Okay, you cannot overly synchronize everything. I'll also tell you what is multi-threading, concurrency, synchronous versus asynchronous, how to do this, how to avoid this unnecessary logging, especially when it comes to .NET, right? It sits on IIS. Most of the applications, as it is a Microsoft product, IIS is a Microsoft product. Most of the times, most of the applications will have Microsoft SQL Server as the database. They can also use MySQL as well. So we're going to talk about all the different database problems, IIS performance problems. I'll also tell you how to optimize the performance with load balancing techniques, SSLs, and what are the typical infrastructure considerations that you need to look at. Because performance testing and engineering now has been associated with not little DevOps practices. It is associated with most of the DevOps practices. You will be a part of chaos and resilience engineering. You will be a part of reliability, scalability. Then you will be a part of observability, where you need to make an APM administrator. Okay, then you will be you will be working from, at some point of time, you need to think like a platform engineer. Platform engineering also comes into place. So performance engineering is not a big surprise to think that so many things are asked. Going forward, each requirement will be unique in performance testing and engineering. Cloud or full stack engineers, developers, automation engineers are also, I mean, they're okay. But when it comes to performance and testing and engineering stack, you need programming, you need cloud, you need containerization, you need orchestration, you need observability, you need chaos and resilience, you need Kubernetes, you need Docker, you need microservices. There is no end for performance testing and engineering. So depending upon what technology you work, SAP performance testing is different, blockchain performance testing is different, IoT is different. So cloud performance testing is different. So when it comes to challenges, so we are going to document. So every batch we are going to, last batch did not go well, but this batch we are going to document all the different scenarios and challenges that are experienced by multiple performance engineers, and even those things will be discussed. So how benchmarking, throughput, when it comes to metrics and all, you have monitoring tools, and I also have profiling in .NET. Like in Java, we also have very good profilers in Visual Studio, like the way you write code in Eclipse IDE or JetBrains IDE for Java, you have Visual Studio. In Visual Studio IDE, you have an inbuilt profiler. You have JetBrains.trace, Redgate's ANS profiler. You have Mem profiler. So what are the things that I'm highlighting here? I'll cover all of that. In addition, if I get some time, I'll also tell you some of the good tools that you can set it up, and then you can explore. I mean, we'll show you on everything practically. That's the motto behind that. So difference when it comes to database performance engineering, right? There are again so many databases. You need to understand the difference between SQL and NoSQL databases. Using SQL databases or NoSQL or vice versa. What could be the reason? Is it performance, or if it is not the performance, if SQL is performing much better than NoSQL, how you are optimizing the performance? What is the strategy or what is the tuning method that you follow for optimizing the performance on my database? Is the some of the like they're like some of the questions from different business vendors. I mean stakeholders and all this stuff. So primarily Oracle database monitoring. Everyone must learn Oracle because the Oracle database is huge, and you need not be a DBA again. Even a performance engineering guru from the database administration side, it is very hard for them to analyze AWR. AWR reports are very huge, very huge. Okay, so you need to know how to take AWR reports, what are the things that you need to look at, how to interpret, uh, how to derive conclusions on that. The ASH active session history report, for example, all of a sudden, if you have a sudden spike in CPU, to know the reason, what is the reason for high CPU utilization? For 1 hour, it is almost 25 to 30%, and all of a sudden, I see a spike of 96%, and it has gone down. If you want to know the reason for a spike like that, you need to take an active session history report to find out which session is actually consuming or taking high amount of DB. Okay, ADDM report is actually automatic database diagnostic monitor. This is another good report which is given by Oracle directly. It is going to give you the problem statement and it is going to give you the recommendation as well. Okay, I'll tell you. So it will identify the problem and it will tell you the recommendation, what are the things that you need to change. But you, as a performance engineer or a DBA, we don't rely 100% on that. We make changes and take actions wherever required. And we again interfere with the values, and we see whether things are going in line or there is some deviation. We are primarily focusing Oracle database, then SQL Server in .NET Performance Engineering, and MySQL database as well. Okay, I'm not sure if I have something like that. Just a minute. Okay, I think I uninstalled it, so no worries. So I'm going to talk about the indexes, benefits of indexing, normalization, query optimization, SQL performance, the different memory allocations, and tuning advisors, how tuning advisors are actually taking part. And coming to this thing, we are going to talk about, like the way I said, data model design, the hardware, how to rightly size the database server, how to choose the database server, and yeah, optimizing database performance strategies, how to do that. These are some of the high level techniques, but we'll go in more depth. And again, coming to the client side, to be on a very lighter note, I actually explain things on GTmetrix, web page test, and Google Chrome Dev Tools. And also you have web page test, you have something like Firebug IS, and you have client side performance testing where you can do that using Selenium and JMeter as well. And I'll tell you how to minify the JSS, how to compress, how to put JavaScripts down, how to put style sheets on the top, what are all the considerations that you have to do. And the last one is, these are some things that I have. I mean, Lighthouse, web page test, and GTmetrix. Page speed insights, we did not actually. I mean, it must be Google Lighthouse. So we are covering all of that. And coming to the monitoring tools, as we get the trial versions, New Relic and Datadog, you can Site 24x7, you will have end-to-end visibility on this tool. We'll teach you everything on this tool. Okay, Dynatrace will not allow the participants to make use of every option that we have in the market. So Dynatrace, what you need, how to analyze all the results is what we'll show you. And New Relic, as New Relic is giving us some data to monitor and all of that, installing the agents configurations will be taught, will be explained very clearly on New Relic and Datadog. Datadog to some extent again will tell you how to parallelly by running the test, by looking at the metrics, will tell you how to analyze and look at different problems. And like I said, right, when I talk about the emerging trends, all of them are AI driven. You have containerization support, you have cloud native monitoring, you have IoT application performance management. There are so many things that have come up. So you read the blogs, read articles, follows the emerging tech trends, and attend some conferences to get more insights on what actually is performance engineering. And I also forgot to tell you there is a little bit of SRE role in performance engineering nowadays. DevOps practices, observability, chaos and resilience. Then you have APMs, APM tools, like even APM administrator. Then you have this thing, cloud. So there are so many things that are coming up. So you need to define your roadmap, and I'll take a technical session tomorrow. And the regular sessions would start from Monday. Monday, it's 29th. And if you ask me what is the end result of this course, every performance engineer with 1 year to 8 years of experience will get complete end-to-end, because the reason is we have a program designed like this. You can see the structure of the program. If you see the program, you have a session 1, and every day we have some sort of we have things like this. I mean, we will actually tell you what are the things that will be covered in that course on that day, and we'll also share you the materials like this. And each of the session would have many questions. Actually, we are not giving any key for that, because we want the participants to work on that. We don't want the participants to stick on some standard answers, theoretical answers. So we'll start from what is a hit, what is a request, what is the difference between a hit and request. So when a hit is not counted, so all these things will be discussed in more detail. And like I said, the end result of the course would be getting a good job with huge pay, with programming added. We don't deal with programming. Learning programming has to be done from your side. Okay. The end result of this course will give you complete insights on Java application performance engineering, .NET performance engineering, and database performance engineering, dealing with multiple web app DB servers. And client side, we also have network performance management. We take you a drive in, we take you into something like network performance using SolarWinds network performance monitoring tool. And I will also explain you about TCP dump analysis, when to take TCP dump analysis, how to analyze that, how to identify performance bottlenecks. So that's all for today, and thanks all of you for joining, and thank you.